Alright, grade 11s, I'm going to do this video in English. I did the formal proof in Afrikaans. So what this thing says is, now I'm going to use this sin rule that I showed you in the previous video to determine certain missing parts within a triangle. And remember, the main focus here is surrounding the fact that this sin rule can be used inside of a triangle that has no 90 degrees. So what did the sin rule say? It said sin A over A, sin B over B, sin C over C, and vice versa is also true. And now kids always ask me which one works the best. It depends on the situation that you're in. Maybe the top one, depending on what you're calculating, or bottom one. You can decide. There's no difference between them. So on the board, I give you a triangle. And this is now a typical calculation with my sin rule. So if I look at the triangle as it is given there, you would realize that there's no 90 degrees at this stage. No 90 degrees. So historically speaking, I would not be able to use sin in this. If I go and I work it out quickly, you would see in terms of interior triangles, angles of a triangle, you would see that if I add 55 and 35, I'm going to get 90, which means this angle at the top here is 90 degrees. So you will be able to, in this triangle, use your normal sin ratios, soos kastua, or you can rather use the sin rule that I showed you. I can tell you now the sin rule is pretty easy, it works pretty cool, and it's pretty easy to apply. So let's have a look here. So it says, the rule says sin A over A, sin B over B, sin C over C. So now I'm looking for, in the sketch that was provided, I'm looking for X. So if I speak of, I'm just going to show you here again, remember in any triangle, if I speak of the sin of A over A, I'm looking for, capital is an angle, lowercase is the side opposite the angle. Okay, so that means, if I'm now looking at X here, I'm looking for the angle opposite to it, and that would be the 35. Those two goes together. Then I've got two other options. Then I've got BC at the bottom here over 90, or I have AB, which is 35 over 55. I'm going to go for this one. The reason for that, I have information. Information is provided. Remember, you want to solve something, so you want to try and keep the stuff you need to a minimum. I only want one thing, and that's the X. So now, which of the two rules stated at the top, which of the two will be the better one to use here? Personally, I'm going to use the bottom one. The reason is because X is the one I want that at the top. It will work if you use the top one, it won't make a difference, but it's just a personal thing of mine. So I'm going to go and say this, X over the sin of 35 is equal to 33 over the sin of 55. Excuse me. So where does that come from? If you now go and have a look at the rule, what I wrote down would be B over sin B, that's what I wrote down, equals C over sin C, if I look at the triangle. But I skipped that and I immediately went into my physical values that is there. So now I need to solve for X, and from here it's pretty easy. That sin 35 was divided, so if I multiplied, or if I take it across, it becomes a multiply on the other side. And remember, I always say this, multiply gets added to the top, division gets added to the bottom. So have a look here. Now I get 33, the sin of 35, over the sin of 55. And from here, boys and girls, it is a question of getting your calculator and typing it in. Very important is, please remember, when you work with your calculator here, important is, I want it on degrees. So I'm going to have here fraction, 33, the sin of 35, close my bracket. Close the bracket. If you don't, it's going to give you an error. Sin of 55, close my bracket, equals, and then you round off depending on what was asked of you. and this answer would be 23.11. So I go back to my page here, 23.11, and what was that? That would be centimeters. Boys and girls, and that is a easy sin rule solution. Okay, so let me show you another one. And this time around, I'm going to change the picture so that the thing that we want now is the angle and not the side. I'm going to quickly show you here. So second example. The second example that I give you looks like this. So in this case, it gives you a triangle, and the triangle says the following. There's a triangle. Let's call it ABC again. It's easy enough. ABC. And then it tells me this angle B is 36. It tells me that angle there is X. It tells me this is 25 centimeters. And it tells me this is 19 centimeters. So the difference between this one and the previous one is that now I'm looking for the angle and not a side. So exactly the same thing says it comes out here. Historically, I won't be able to use sin and cos in here, but with the new rule, it opened a wider perspective for us. So the wider perspective says, if I'm looking for X, now look here, now I'm looking for the angle. So personally, I'm going to go for the top equation now, because the thing that I'm looking for is at the top. But once again, doesn't matter which one you use. So look here. I said that the sin of X, the thing that I'm looking for, divided by, now remember, we're working with angles and sides, opposites. So I'm going to use these because it's provided to me. So I'm going to go for the sin of X over, you just get black back here, 25 is equal to the sin of 36 degrees over 19. Now I go and I say, all right, that means to me, I'm going to look for the sin. So to solve the sin, I'm going to have the sin of X. Remember what I said, 25 goes across. I'm going to multiply it. If I multiply, add to the top. So I'm going to get 25 sin 36 over 19. So in grade 10, you were taught that if you're looking for the sin, it's shift the sin. If you have the sin, it's normal sin. So what it means to me is I'm looking for the angle here. How am I going to find that? By making use of the shift sin function on my calculator. So if I open up my calculator, I'm going to type in 25. Let me just get it in fraction format. 25, the sin of 36 over 19. That was given on the other side for me. Excuse me. And I press equal. But that makes no sense. It means the angle is less than 1 degree. So what do I do now? Now I type in shift the sin of that answer that I just got there, and I have an answer of 50,66 degrees. So X is equal to 50,66 degrees. Please remember your degree sign as well. Now, one thing we've got to remember here when we're working with sin, boys and girls, is the fact that what we did here, and now I take you back to your chapter on trigonometry. If I can quickly just grab the calculator back here and just type that in again. I got 25, the sin of 36, close my bracket, everything over 19. If you go back to your trigonometry chapter, you remember we did general solutions, if I'm not mistaken. And general solutions said that if I take sin and you look at this value here, before I said shift, it said positive. So if it's positive, according to me, sin can be in two places. Sin can be either in your first quadrant or your second, because according to this diagram, it says CAST, which means sin would be positive there and in the second. So that 50.66 is found where? In the first quadrant. That's the angle there. But where else could I find an angle that will give me that same answer of 0.77 in the second quadrant? Now, how did we get to the second quadrant every single time? We used our reduction rule. What was the reduction rule for the second quadrant? The reduction rule said 180, and I went back inside minus. And this is only, boys and girls, only with the sin rule that this happens, sin rule. It does not happen with any of the other rules, only the sin. So now I go and I say, all right, that's fine. I've got no problem with 50.66. Great stuff. But I'm going to go and find my second one. And the second one said this. It said that x is equal to 180 minus 50.66. And remember, I'm not adding here plus or minus 360k. Why? Because this is not a general solution. I'm doing to the point here. So if I now grab my calculator and I say 180 minus 150, not 150, sorry, 50.66, and I get an answer that says 129.34. So this one is then 129.34 degrees. Very important though, grade 11s, is you just need to go back and test these two answers, because not both of them will always work. Now, what do you mean by testing it, sir? Okay, it's very easy. So I'm going to just quickly redraw that triangle. So I had the triangle that I gave you at the top looked like this. I'm going to do two of them. So it's called A, B, and C. A, B, and C. And this was set as 36. 36. So what I now basically calculated was, in the first one, that x, this angle here, is 50.66. Or in the second one, I said 129.34. So I need to make sure that with this what was provided, are there enough left to make an angle at C? So if I now take 180, I subtract 36 and I subtract 0.5066, I get an answer of 93.39. So that means this angle here is 93.39, which is more than you can happen. It's you're capable to do that. So I feel comfortable with that. And remember, the sketch is not on scale, so you're going to tell me, so that can't be that angle. Remember, it's not on scale. It doesn't matter. We just proved it. If I go next door, and that's normally where the problem now comes in. If I go next door and I say 180 minus 36 minus 129.34, sorry, 0.34, then I'm going to get an angle of 14.66. So, is that possible? Can I draw that? Yes, it's a very small angle, but it is possible. Which means what to me? It means that both of these answers are applicable in this situation. So when will it not be applicable? So let's say, for example, just example, you did not get 129 here. You got something like, let's say, 172 degrees as your second answer. So what's going to happen then is, if I then take my calculator and say 180 minus 172 minus 36, now you're going to get that. And grade 11s, how on earth do you want to draw a minus 28 degree angle? Now you're going to tell me, yeah, says the direction. Nonsense. We're working with interior angles of a triangle. It can only add up to 180. So it can't be more than that. So 72 and 36 is more than 180. Definitely, then it won't work. So grade 11s, be careful. Be on the lookout. What do I need to remember? When working with sin rule and angles, I can get two options. Just make sure if the second option is a workable option in the example that you have. Good luck. I hope you understand, and enjoy the work that follows.